Hey, what's up, everybody? This is Bite Me back with another video. Wanted to do something to pretty much kill two birds with one stone. Essentially, what I'm doing is demoing how to use Jupyter Notebooks, or not really how to use them, but how you can use them, and just as well as demoing a little component of a project that I'm working on. Don't want to release too much information about the overall project, but essentially this particular component of the project, it was a very difficult task for me to execute. And I was really proud of myself after I got it done. But one of the things that I was fearing is that, because I know there's so much more to code and so many different parts to work on, is that I didn't want to finish this, go back a month later, and then not know what's going on in any of the code that I wrote here. Even though I could probably read through it and figure out what's happening, it just would save me some time if I can find a better method of documenting, oh, how do I create this again, or how do I do this again? So that's what I decided to start utilizing Jupyter Notebooks. Now, Jupyter Notebooks is a tool that was I don't necessarily know the origin of it. I just know that it's awesome. It's a tool that people utilize, data scientists utilize, especially for graphing, for AI demonstrations. If you wanted to do some kind of a plotting demonstration, you see that a lot. At least that's been my exposure to it for the most part. But in my particular case, I wanted to be able to document out how some of the use cases of my code was completed, or how to get after certain objects in my code, without actually doing it within the IDE, or comments in a function. So essentially, I just give you guys a basis of how I start out writing code. I usually start up with like a module called dev underscore in the module that I'm working on. And then from there, I'll import that module in, and I'll start doing different things in multiple separate functions to get after my end goal. So you can see, like here, I have 5 different functions created there, all doing different little things here and there. But until I create the main package, or the main object, or the main methods, or all the methods associated with the object, this is the phase that I end up going through first. I call it my dev stage. So as I do that, you can see here that I got a couple of commented out lines of code. Then I have some variables being created here, and then I have more variables and more functions being called. And here I got some more stuff going on here, and I got a bunch of code, commented out code here, and then I got me trying to print something out here, and then I have this file being created here. So it's like, if you do very descriptive function names, you can pretty much get an idea of what your code is doing. But it doesn't really help is if you need to start working with other developers and they get this stuff, and you have to spend more time explaining to them what your code is doing for them to actually get a job done, when essentially the job that it would have took them to write, that if I would have gave them the right documentation, could be less than 5 minutes. So it's all about the documentation. So I was just trying to figure out some more intuitive ways to do it, and that's where Jupyter Notebooks come in. So this development function here that I'm doing here, the name is arbitrary here, but essentially I just wanted to say, okay, I wanted to build this particular example is building a blank DISA checklist file. So here I create different elements and a bunch of all this other stuff. So I essentially took the components of this function here and then imported it into a Jupyter notebook file. When I say import, it's just copy and paste. But what's really cool about the Jupyter notebooks and just little components of it is that it uses markdown, and then it uses code execution blocks, similar to what you can do with like your README documents for GitHub documents. If you use GitHub or anything like that, or if you do any kind of markdown style coding, you can use the syntax from that to do bolding and headings and all this other stuff within the file itself. But what Jupyter did is it kind of takes all that and puts it into a really nice, awesome web-based format, and then you can export it into multiple different formats like PDF. It's Python-based as well, so that's something to keep in mind. But you can export it as a PDFs. You can export it as HTML. You can put it into a Python script. I mean, there's so many different exportable types that you can use, and it's all based off of this base. But essentially, just going down here, you can do markdown and actually have text in there. And so instead of the text being comments inside the IDE, which to me just doesn't look good, and it gets very jumbled up, and then I'll have a function with 30 extra lines and actually 2 lines that are actually doing stuff, but the most are comments. So that kind of throws me off a little bit. It's personal preference. I know other people are probably like, get over it, but hey, anyway. So this is really good for me and really intuitive to me, where I can actually write a paragraph down there and actually go through and explain what's happening and actually have live code execution. So for example, one of the things you have to understand too about Jupyter Notebooks, and this is what kind of threw me off, is that it runs in a linear fashion from top to bottom. So as you have different lines of different lines of code here, if you want to execute them, you need to make sure that you execute if you have anything dependent on the code above, make sure that the code above gets executed first. For example, my imports, if I was to run this line of code here, it would fail if I didn't try to run this import first. So I'll run this, and it'll update it so that I ran it again. And then from there, I'll go ahead and run this. And then what it'll do is that what's awesome is that you see how I have this print statement down here. And so on the above markdown text here, I mentioned that each element has a toJSON method that I created that's able to extract the information created from the object and then turn it into a JSON output, which could be used for other purposes, or if you're doing report generation, different things like that. So it just gives you some extra flexibility with the information that's in the actual element, to be able to interact and do some cool things with it. So in order to show that worked, because it actually processes live code using a Python interpreter, I was able to print the actual information out, and that's why you see this documentation here. You see this information here. So like, show you guys I'm not BSing you. Go down here, if I change that to 7 and I hit run, you see it changes to 7 here. So this is actually live code execution. And then again, it's pretty descriptive, pretty much what I said. I'm going to create a STIG info, asset, and vulnerability elements. And then for the example, I'm going to create 2 vulnerability elements to just demonstrate the ability to add vulnerabilities to an existing checklist file. So that's what I'm doing here. You see I create the STIG info element. I created my asset element. There's my vulnerability element A, and then element B, with the different information associated with it. And then, like I said, each of those elements have a toJSON method associated with it. So I'm able to export the information in the JSON format, which I like working with better. These DISA checklist files are XML based. So, and XML is nice, but depending on who writes the XML and how well the XML is written, it can be a pain in the butt to deal with. And that was essentially my problem with the DISA checklist file. So essentially, in the processes, I created a converter and a create generator of the XML and JSON formatting data. So that's essentially what this is doing for us. And then here, I mentioned that in order for us to start, we need to create a base element structure for the checklist file. So we're gonna have to pass the asset information and the STIG info information into that base checklist. And to create that, and then I'll get a root element. Then the root element I will be able to run this add vulnerability function. I'll pass the root element in, and then I'll pass the vulnerability that I want to add, and then it'll create the root element again, or it'll just replace that memory space. And then same thing at the bottom here. And then the root element has a function called toFile, and I just specify the file name that I want, and then from there it'll actually generate the file name for me on the file system. And then what's really nice, because like I said earlier, this is using markdown, you can use markdown syntax. And so I'm a very, very, very beginner entry level with all this stuff. So a lot of it is still Googling it up and figuring out how to do certain things with it. But one of the things that I found out you can do is you can insert images. So looking at this, you see that this is an actual syntax of what an image, inserting an image looks like in Markdown. So I just went ahead and hit run, and then this is an actual, I did a snippet of the DISA STIG tool that I had opened up, opening the checklist file that I generated. Just showing that it actually works and the information is there as far as the computing information and all that other good stuff. You know, this isn't a replacement for doing testing or anything like that. I just want to make this clear. This is mainly for documentation. There's other tools out there as well, but for me to be able to do something quick and easy, and then something that looks really, really clean and really easy to use, and then what's really cool about it, on top of that, is that GitHub has support for it. So here on the GitHub, it's a repo that I have up. I'm able to actually then go ahead and put this Jupyter Notebook onto my GitHub account, and then it's actually then able to process it as if it was looking at it from the actual Jupyter interpreter that runs on your PC. So that's one of the really cool things about this. Right now the text isn't showing because I actually have it referencing a local file on the file system, so that's why it showed working on this instance of it. So Jupyter actually runs a web server on your computer. So when you just specify the command. I don't know if it's going to show here. Yeah, it doesn't going to look like it's going to show here. But essentially what you're going to do is you're going to run it's a Jupyter command. Here it is, Jupyter Notebook. And then you run the notebook that you want to run, and then it'll start a web server instance of it, and then you're able to edit it using the web interface. So that's why the image loaded here. But if I was to take that image and put it on some kind of a like Google shared drive or something like that, I'd then be able to then access that and then show that on my GitHub as well. But I also have the image available inside the images file and the root anyway, so to each his own. But just wanted to, like I said, show you guys the method of how I get after some of my coding tactics, and then some of the tools that I'm starting to pick up as I dive more into the DevOps side of this stuff. Just a word of advice to any network engineers that are starting to, who kind of want to understand what the next thing to do, to study and all this stuff. Personally, background of myself, I definitely went for the attempt of trying to study for the CCIE, which I was very close on the service provider. But among my studies, some of the things that I saw what's happening with the industry didn't necessarily fit what the certification is going to allow me to do. And not to say that the service provider stuff or the route switch stuff is going to go away, but I feel like the real cutting edge stuff and some of the more dominant, more in demand skill sets that are starting to come is programming. Actually, the last couple of recruiters that I spoke with, they have made an interest in me just mainly because of my development skills. I've got at least 10 years in with the network engineering stuff, but as far as being able to code and translate the network engineering stuff into software, it makes you a super, 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 super valuable candidate. I mean, it's ridiculous. I would go into emails and show you guys emails, but it's just amazing the opportunities that open up and the type of positions that kind of get offered to you just by learning this stuff. The traditional network engineer, I feel like in the next 5 to 6 years, it's going to be treated more of a help desk position more than a high level operations job, because a lot of the things that we do, let's face it guys, it's redundant, it's repetitive, and it can be automated. And the reason why a lot of the network engineers today make the money that we do, or we get the opportunities that we do, is because only we know how to do it. But once you figure out how to automate that and turn it into a push button software tool, that skill set on the floor is no longer needed at the masses. You'll probably have 1 or 2 high level guys, and the rest are just going to be your low to mid level support techs. So that's just my personal vision of where I see the industry going. And I mean, just look at companies like Facebook or companies like Google or Amazon. First off, they're not even hiring engineers with just traditional CCNA, CCNPs, or CCIEs. They want some kind of a programming background. And then the number of people on these company staffs, you would think is going to be in the hundreds. You would think, oh, Facebook is dealing with maybe 100 plus engineers, which is probably not the case. I think they're dealing with less than 30, and they have different phases of the engineering aspect of it. But it's pretty insane the amount of network engineers that they have on staff for the infrastructure that they support. Just goes to show that the future is going to this software driven architectures. In that, if I feel like if you want to be ahead of the game and get the money and get the exposure and being on some, I think, revolutionary projects, learning a programming language is definitely a beneficial thing. So just my 2 cents at the end. I didn't really want to go too much into that, and I didn't expect it to go as long as I had it go. But I feel like it's very important to understand, especially for engineers, people getting into the networking field, who definitely should definitely understand and learn the old CCNA, CCNP, and some of the high level CCIE stuff like MPLS, L3 VPNs, L2 VPNs. Definitely learn that stuff. But I mean, if you could figure out coding wise how to implement maybe automating configurations or automating maintenance or automating path manipulation, generating BGP configurations or designs, it's just different things like that just becomes super beneficial for you as an engineer. So yeah, I hope you guys enjoyed the video. See you later.